Hello everyone. Today we're going to go over how to modify the UART receiver module from the previous video to be able to receive a burst of bytes instead of just one. Because before it was in this configuration here where it can only take in 1 byte at a time through its RX line and display it on the LEDs. But what we're going to do is we're going to modify it so that 64 bytes in a row can be sent in through the RX line. Then the UART receiver is going to take that stream through the RX line of serial data, convert it into its result and done to get this nice parallel form, which we saw how to do in the last video. It does that. So we're going to send in 64 bytes we're going to send in 128 bytes with our Python program. Then the UART receiver is just going to continuously drive its output based on that. Then the receiver RAM interface is going to take each pair of bytes, concatenate them, so these first two get concatenated, and then we're going to write that into the first address. Then we're going to take the next pair, write them into the address after that. Then we're going to take the pair after that, write them into the address after that. And we're going to keep going continuously until we get to write address 63. Because we're only going to write in 64 values. But because each value requires 2 bytes, that means 128 bytes need to be sent in from the computer. So yeah, the receiver RAM interface is going to take in the UART stream, and then it's going to drive the write bus to be like this. So then the RAM unit will store all of that data, and then we can use switches to read the address. This read enable will always be 1. This will be connected to switches, and then this will be connected to LEDs, and we can read the value. So let's look at the code now. So the receiver RAM interface, this just defines the ports and signals. The main logic is here. So for the main logic, well, all registers are initially 0. So when we get our done pulse here, if done is equal to 1, so state is going to be 0. All registers are 0 initially. So when done is 1, done index is a register that's going to be originally 0. So we're going to take this branch when done is 1. So when done is 1, we're going to store the result, which in the initial case, in the very first done pulse, is going to be B0. So B0 is result. It's going to be stored in this register, stored byte that we defined here at line 168. So we're going to store that, then we're going to increment the done index, and then we're going to wait for the next done pulse. So when the next done pulse comes, because we incremented done index, this condition is going to execute. Then we're going to drive the write data in that write address, so then these 2 values will get written out. We're going to increment the count. Then we're going to go into state 1, where we just drive the write enable pulse and reset everything back to 0. So then we can do it all again for the next pair. So once that happens, when the third done pulse right here happens, B2 is going to be result. So we're going to store B2 in stored byte. Then in the fourth pulse here at B3, this statement's going to execute again. And then we're going to shift out B2 here, because that's what was stored in here. B2 was stored there. Then B3 will be stored there on the fourth one. And count will be 1 this time because we incremented it the last time. So we're going to shift out 1. and then we're going to increment the count for the next time. Then we're going to go to state 1, 2 to drive the next write enable, and we're going to repeat that process indefinitely until we get to the 64th time, where everything's the same, but then we set the count to 0 to wrap around. So we're going to move into the demonstration now, or actually let me run a simulation just so you can see that. Oh, yeah, here it is. So this is the simulation. We have our RX line, very crazy. The computer is sending in all these values, all these bytes. Then the result in done pulse gets interpreted from that RX stream, just like that. We take the 2 bytes, concatenate them, write them into address 0. Pick the next 2, concatenate them, write them into address 1. The next 2, concatenate them, write them into address 2, and we just continue indefinitely until write address is 63. So when it's 63, it resets. So now let's pull up a Python program so we can send values. Just clear that. So let me get my let me just get it set up real quick. Okay. So this program, it's a different program than the last one. In the last one, we would send 1 byte at a time. In this one, we send 128 bytes. So right now we're sending all these bytes in. We just did that. So we go to address 0. You get 4, 5 there. Yep. Then after that, it's 5C, which is there. Let's go to a random address. Go to address, I don't know, 12. So to address 12, we have 80, so we have 80, then E0, so that's correct. Go to address address 8, let's see what that is. So address 8, it's matching 6 here, 8, and DF. So the computer successfully sent this. So let's say we want to send another burst of 63. Because all of these values here, they're randomly generated. So if we do it again, it's now going to send in another burst of 128 bytes, or 64 address worth of stuff. So set to 0. B0 should be the first 8, so 0, B, that's good, and then 2D, yep, that's good. So go to address 3. Address 3 should be B5. 5. Yeah, that's working. And 5-1. Yep. That's good. Go to address 13. Let's try that one. Address 13. 2 1. Yep. And 4 0. Yeah. 0 4. Okay, it's working. Adjust 13. Let's try one more burst. So we're at adjust 13. So now it's 6 and 1 and D3, yeah. So we have D316 at address 13. D316. So it's working. So yeah. So that right there is how you would use the UART receiver to process a burst of 64 values from the computer, where the computer sends 2 bytes per value. And as you saw at the end there, we send burst after burst. So the write address here, after when a new burst starts, it would be 63. Because yeah, it's 63 at the end, but then it wraps around when it starts again. So it'd be like that. Alright, so from this, you should be able to modify the receiver RAM interface to implement the behavior you want. Once you have the behavior you want envisioned, like if let's say we wanted to use 3 bytes instead of 2, you would just have it concatenate 3 and then write those 3 to address 0, and then the next 3 to the next address, and so on. So you should know how to make, now that you know how it works, for this one you should have no problem making the slight modification to change it. Or if you want, you can use like these first 2 bytes for the write data, then these 2 bytes to control where this write data is sent. Because right now it's just having to be 0, 1, 2, 3, 4. But it could be where instead of it being 0, B2, B3 controls where the write address is. And then it would just, instead of this, it would be B4, B5, and then this would be B6, B7 for the write address. So you can choose to do it like that too. But yeah, that is how you send a burst of values. And yeah. So the top level module just combines them all together in the way shown here. Nothing special about that. So yeah.